So you should have learned about equilibrium in Chem 3A, or whichever class you had as a prerequisite. But you may not remember, so we're going to go over it kind of quickly here. We know from chapter 15 that reaction rates generally increase with increasing reactant concentration, right? So if we increase the concentration of hydrogen or increase the concentration of iodine, the rate of the forward reaction is going to be faster. Well, in a reversible reaction, it can go in both ways. So what if we increase the concentration of high? That's going to increase the rate of the reverse reaction, right? And so the forward reaction and the reverse reaction are going to kind of battle it out until they come to agreement where forward and reverse are equal rates. And so we've got reaction happening, but overall, there's no change. If we start with just these reactants, the reaction will go in the forward direction, it'll produce high, and there won't be any reverse reaction until we've got some high over here. And as this increases, the reverse reaction rate increases. So this is illustrated here. Concentration versus time. We start out with no high. We've got hydrogen and iodine. As the reaction proceeds, these concentrations go down and the rate of the forward reaction goes down. As that happens, it produces high, the product. High. And because this concentration is increasing, then the rate of the reverse reaction increases. So initially, we only have forward reaction. As that proceeds, though, the reverse reaction starts to get faster and the forward gets slower until they meet in the middle somewhere. Any questions? Once we get to this equilibrium, the concentrations of reactants and products do not change. That doesn't mean that nothing is happening. It's not that the reaction stopped. Both reactions are still occurring. Products are being formed and products are going back to reactants. But they're just equal and opposing, okay? A little bit like an airport. So if you took a snapshot of a busy airport, I don't know, Phoenix, and you counted how many people were in the airport, and you waited an hour and did it again, the number would probably be about the same. Is it all the same people? I hope not. Because if it is, then there's some problem, which is why you like to fly through Phoenix instead of Dallas-Fort Worth. You can ask me about that later. So it's not the same people because some people are coming in and some people are leaving. But in the middle of the day, the coming in and the going out is approximately equal. So the number of people stays the same even though it isn't the same people. So that's what an equilibrium does. Products are being formed, reactants are being formed. So it's actually very busy, but looking at it as we do, we can only measure concentrations. It looks like nothing's happening. So what we define as a dynamic equilibrium is the condition in which the rate of the forward reaction equals the rate of the reverse reaction. Both are still happening. The concentrations no longer change, but they are not equal to one another. Okay? That it's at equilibrium doesn't mean that you've got half this and half that. That's where the equilibrium constant comes in. Some things you've got almost all products. Other things you've got almost all reactants and only a little tiny bit of products. And I can't answer why right now. So the relative concentrations are just going to depend on the rate constant for that chemical reaction. Any questions? So the book uses I kind of talked about an airport, but this is like a population analogy. In an earlier edition, it wasn't country A, it was Narnia. And it wasn't country B, it was Middle Earth.
Awesome.
Right? I'm like, that is so awesome. And then they changed it. I don't know if they got into copyright issues or what, but anyway, I'm using the names. So Narnia and Middle Earth. So we got a lot of people living in Narnia, very few people living in Middle Earth. It was kind of crowded over here, and the grass is always greener on the other side of the fence or the border, right? And so they're looking, it's like, well, there's a lot of opportunities over here. So initially, there's going to be a lot of people moving to Middle Earth because there's lots of space. Will there be any people moving to Narnia? Probably, but not very many, because there aren't very many people there, right? As the migration continues and more people end up in Middle Earth, because we have more people here, people are naturally not content with what they have, right? So they're going to go find something better. It's like, well, we want to move over there, right? And so you'll get more and more people moving over here. At some point, the migrations will equal. The rates will equal, but the concentrations are not going to be equal. The populations are not going to be equal. Because, and I would prefer Narnia because I think there are fewer monsters, right, trying to kill you. Middle Earth seems like a pretty dangerous place, although someone yesterday pointed out that they have really good food. Where the hobbits live, they eat well. Anyway, so if this is an undesirable place, more people are going to live over here, right? Any questions? It's not going to be equal. Okay, which statement does not apply to chemical reactions in dynamic equilibrium? The rates of the forward and reverse reactions are equal. Is that true? Yeah. The concentrations of the reactants and products are equal. That's a no, right? That's what we just talked about. The concentrations aren't equal.
That would be the CU though, right?
Thank you. I'm jumping. My bad. If I was editing these videos, then I could just take that part out. The concentrations are constant. Yes, this is true. This is the one I was thinking about. The concentrations are equal. Is that true?
Yeah.
That's the false one. That's the answer. Muffed that one pretty good.